Welcome back. In this video, we are going to discuss about straight line equation forms, continuing the gradient that we have learned in the previous video. So first things first, on top of gradients, we need to know about intercepts. As you are familiar already with the Cartesian plane, I can draw it quickly here for the x-axis, and then here is the y-axis. When you have two different points, you can create a straight line. Well, let me just adjust the point to be other than that. So it is visible here. This is the point 1 and this is point 2. You can calculate the gradient and then you can create a straight line continuously. So the intercept is what is crossing or passes through the y-axis and the x-axis. Here, x-axis, y-axis. So here, the point here, we call it the y-intercept, and then here is the x-intercept. Okay, so let's say if I have another line like here, so the y-intercept is down here, and the x-intercept is over here. So let's write the definition for x and y-intercept. So x-intercept is the value of x where the line cuts x-axis. Now, for the y-intercept, it's the same thing, but then it is on another axis, which is the y. So let me erase here. So y-intercept is the value of y, where the line cuts y-axis. Okay, so now we shall focus on also writing it in the coordinate and understanding it. So because x-intercept is here, right? And this is the central 0, 0. So the origin point. And this means that when x-intercept happens, the y value is 0. So the coordinate would be something like 0, the x-intercept, let's say we can say x1 or x-intercept, comma 0. For y-intercept, it is the contrary. The x value stays at 0, but then the intercept either happens on top or down on the y-axis. So the x coordinate is 0, and we have y-intercept. Commonly, in the straight line, we say that the y-intercept is c, symbolized by c. Okay, now we are ready to go into the next slide. So another thing that we need to note is about parallel and perpendicular lines, the relationship that maybe you have learned in your previous studies, but let me just recall it back. So if there are being mentioned that, two lines are parallel, this means that they have the same gradient. So the gradient of one line is the same as the gradient of line 2. And if the line is perpendicular, or you might see the symbol in this way. Okay, this implies that the gradient of one line is the negative reciprocal of the other line. So let's say if the m1 is 2, then the gradient of line 2 is -1/2. Or if you cannot really remember this, you can also memorize it this way. The gradients being multiplied is equals to -1. So, you have choice whether you want to memorize here as the negative reciprocal of other gradient, or you solve for this equation. So the gradient of two lines when being multiplied is -1. All right. Now we are going to get to know the other, there are three forms of straight line equation. So the first one is we can get it from the understanding of gradient. So when we learn gradient, gradient is defined by y2 minus y1 over x2 minus x1, and this equals to gradient. And because we want to get, a lot of points, a lot of points, basically infinite points in order to create a line. So we can just pick a point, and as long as the other point, move in the movement of m, right? So we can have that line. So we generalize the y2 and x2 into here, y and x, because any points that we take, right, with respect, or in relation into that point, must have the same gradient. So this means that whether I want to take this point here, right, this is the point 1, okay, x1 comma y1, okay, whether I take the point here, or I take the point here, or I take the point here, related to that, right, all related to that, or even I take the point here and related to the P1, I must get the same gradient. That's why I generalize this as x comma y, because I want to take the x comma y at any other point. So now, as we have got this, we can cross multiply. So we get the point gradient form, y minus y1 equals m x minus x1. Okay, so this is the first equation, the first form. We call it point gradient. Okay, another thing is that because we love to put things into isolating the y, right? In a sense, we want to make y is a subject of x, right? We want to input something on the right-hand side to get the value of the left-hand side. So we can rearrange this form in order to get into y equals mx plus c. This is gradient. This is gradient intercept form. It's very self-explanatory. So this is called point gradient because you can just use a point, substitute that, and you substitute the value of m to get the equation, where this is gradient intercept form because you substitute the value of gradient, and then you substitute the value of y-intercept in here. All right, another thing is that from this arrangement, or you can rearrange into this form, ax plus by equals d, and this is called general form. And sometimes in the exam, you can be asked into this form. So basically, you are putting everything into the left-hand side, and you are going to equate that to 0. And don't worry, you will be able to do these 3 onto when I show the practice questions next. And for this general form, maybe you're asking, what is happening with the a and b? Because this is a beautiful 1y, and this is 1y as well, right? There is no another coefficient in the front. This would happen if the m is a fraction or a rational number. So you need to maybe clear the denominator, so then you'll get all of this a, b, and d is the form of integer. Commonly, especially here, I will note it, a, b, d is in integer forms. And especially for a, they would love that to be positive integers. Okay, now we are going to go into the practice. First, let's practice about the finding the gradient and the intercepts. So now here the question is for us to find the gradient, and then the y-intercept, and then x-intercept. So we have 3 tasks of the straight line equation of this. All right, so in relation to what we learned before, the 3 forms, we can break this down into y equals mx plus c. So we can just break it, y equals 2 over 6x minus 3 over 6. Because this is the denominator, so you can split that. Okay, now we can simplify into y equals 1 over 3, x minus 1 over 2. Okay, so now we have a lot of informations here. The gradient is m is clearly 1 over 3. The y-intercept is here, the plus c, which is minus half. Okay, now in order to get the x-intercept, right, what we need to do is we solve for y equals 0, right? Take a look here. Y-intercept, you get it when x is 0. So you substitute x is 0. 0 times 1 over 3 is 0. 0 minus half is minus half. On the x-intercept, y equals 0. So, we do that here. So 0 equals 1 over 3x minus half. So then we can multiply by 6 in order to clear it. So 0 equals 2x minus 3. So 3 equals 2x. And then we can simplify by dividing by 2. I'll make it clear here. Over 2 over 2. So x is equals to 3 over 2. So that's our x-intercept. X-intercept equals 3 over 2. So this is what we have for the answers. So we can try to, substitute that into here or here. 3 over 2 times 2 is 3. 3 minus 3 is 0. 0 over 6 is 0. So that's correct. Okay, and if you're unsure, definitely we can use the GDC to solve for the x-intercept, right? So we can just write this equation equals to 0, and I will show you in both calculator, the Texas Instrument 80A4 and the Ti-Nspire as well. So first, and here, Ti-84, what we can do is we solve for x. So we use math. We're going to go into a numeric solver. So the first left-hand side, y equals 0. And then on the fraction here, it is equals into 2x minus 3 over 6. So we create a fraction. Let's just put it back here. Okay, 2x minus 3 and then over 6. All right, and then we solve for it and we get that the x is 1.5, which is 3 over 2 in fraction. Another way, we can put that into fraction. The equation here, y equals 2x minus 3 over 6. And we see the graph. And what we're trying to do is get the x-intercept over here. So second trace is the calculate. We are going to go to get the 0 or the x-intercept. So we pick the left bound, something lower than that, and we pick the right bound, something higher than that, and our guess is in this part. So we get it, the x is 1.5. It's the same answer as what we have before. We can also check it in another calculator, Ti-Nspire. We can use same numeric solver, menu, 3 algebra, and then we go into 6 numerical solve, and we put the equation 0 equals, and we make the fraction 2x minus 3, and then over 6. In this case, we want to solve for x. So we get it that the x is 1.5. If we want to sketch, we are going to go into here. We are going to graph it. So we put the y into the function here. So we make the fraction again. And then we input 2x minus 3. And then write down here is 6. And now we are going to get the x-intercept here. So menu, and then we go into here, analyze, and we are going to get the 0. So this is the left part, this is the right part. Here we can see the coordinate is 1.5, 0. All right, so those three are the same as 3 over 2 when we do it by hand. Okay, of course, the calculator skills need to be on for you both, AA and AI students, but then AA student must also be able to understand how to solve it by hand. Okay, now we're going to the next slide. Now practicing to write the forms of straight lines equation. So now find the equation that is passing through this point, 4, minus 3, and then the gradient is 1 over 4, and they basically ask us to write in all forms. Okay, so first is the easiest way is, here, point gradient, right? Because the basic function is, y minus y1 equals mx minus x1. If you forget about it, don't worry. This thing is available in your formula book, topic 2, functions. Okay, so here we just substitute the point. So y minus y1. The y1 here is minus 3. So we need to write it, a bracket. And the gradient is 1 over 4. And then x minus x1 is 4. All right. So we need to tidy up the minus signs here. Y plus 3 equals 1 over 4, x minus 4. This is the point slope form, right? So we're done with that. Now, from here, we can go into general form first, or gradient intercept first, is up to you. But let me start with the gradient intercept. So from here, what we can do is we move the plus 3. So we isolate the y, because gradient intercept is, y equals mx plus c. So we expand here, 1 over 4x. We expand it here, become minus 1, and plus 3 move become minus 3. If it's a bit confusing, I will write it here, minus 3 and minus 3. All right, so now we can finalize our answer here. Y equals 1 over 4 x minus 4. And this is our gradient intercept form. This is telling us very clear that the gradient is 1 over 4 and the y-intercept happens at minus 4. So it is down here, minus 4, and positive gradient means going up like this. All right, general form. From general form, we can basically go from here, tidying up into general. So what do we need to do is we are multiplying all these things by 4 because we want to kick out the denominator. So I will write it down there. We multiply by 4. So 4 times y become 4y. And then 4 times x over 4 is x. And then minus 4 times 4 become minus 16. Now we can tidy up. So we can just move, because we want the x to be positive, we can move 4y into the right, and then we move the minus 16 into the left. So minus 16 become positive 16, the x stays there, and this is minus 4y. And we can switch the left and the right hand side to finalize our answer. X minus 4y equals to 16, right? This is positive 1x actually, and we love to just write it in the positive x manner. So we have all the answers that we need. But yeah, so those are the answers in the 3 forms. In the point slope, which is the first one, in the gradient intercept, which is the second one, and then in the general form, which is the third one. And sometimes if they want the equation to equals to 0, so what you need to do is x minus 4y minus 16 equals to 0. All right, now it's time to go into another question. Practice about parallel lines. So find the equation of the straight line which is parallel to that one and pass through the point of this. Okay, the information is parallel and then pass through another point. Well, we can make equation of straight line, if we have gradient and point, right? Or gradient and intercept. That's the easiest way. So because we already have a point, our task is to find the gradient. The gradient, because this is parallel to this line, we can find the gradient of this line first. Now let's call this the line 1. Okay. So, we tidy up the line 1. 2x minus y equals minus 3. So because I want to isolate the y, I can just move the minus y into the right, become plus y. And then here, into the left, become plus 3. So I'm going to have y equals to 2x plus 3. All right, so we know that the gradient of line 1 is 2, because here y equals mx plus c. Okay, So because this is parallel, right? So M2 is also equals to the M1, which is 2. And now because we have the gradient and we have the point, we can get the equation into point gradient form. So I will rewrite the formula based on formula book is y minus y1 equals m bracket x minus x1. Okay, so from here we can substitute it. Y minus minus 1 become positive 1 equals m is 2. The x minus x1 is 3. Okay, so this is the equation of straight line. You can stop here. If they ask to be in the gradient intercept form, so you need to continue on. I'll write in blue, y plus 1 equals 2x minus 6. And then we tidy up, y equals 2x minus 7. This is the gradient intercept form. And if we want to finalize into the general form, okay, so move the y into the left, from left to right, and move the minus 7 into the left. So we isolate it there. So we get it that 7 equals 2x plus minus y. And then we switch the left with the right-hand side. So this is the general form. All right. Now we shall practice one more, which is the perpendicular lines. So we need to find the equation of the straight line, which is perpendicular into this and pass through the point. Okay, so again, we can name this line as the line 1. So we simply see again on how to get the gradient, which is turning that into the gradient intercept form. So we isolate the y. So first we move the x. So 2y equals minus x plus 6. And then we divide everything by 2. Y equals minus 1 over 2x plus 6 divided by 2 is 3. So we get that the gradient of m1 is minus half. Okay, because, the gradient of another line, which is this line, is perpendicular to the gradient of line 1. So we can say that the gradient of line 2 is the negative reciprocal of gradient 1, right? Or if you put the formula, it will be like this, which you will get it in the 2. If you want to do it in some sort of instant way, the language is negative reciprocal. So you change the sign. This is negative, become positive. And then reciprocal. This is 1 over 2. So you flip that into 2 over 1. So it's 2. Yeah, so that's what it meant. I meant when you say negative reciprocal. You change the sign from negative into positive, and then you flip over the fraction. So if it's 1 over 2 into 2 over 1, which is 2. Or else if you're confused, you can just substitute the formula, m2 equals minus 1 over m1 into the GDC for the AI students. And we get it, the gradient here. So now, because we have a gradient, and also we already have a point, so we can get the equation immediately. So y minus y1, so this is because negative, change sign, plus 1 equals the gradient is 2, and then bracket x minus x1, change the sign, become plus 2. All right, this is the answer in the point gradient form. And if you want to get the other forms, I will get you here. So y plus 1 equals 2x plus 4. And then we isolated the y. So it's 2x plus 3. And in order into getting it into general form, so we write it again, minus 3 equals 2x minus y. So, we just flip the side. Okay, earlier here, the plus 3 move to the left, become minus 3. And then the positive y move to the right, become negative y. And this is the finalizing answer. Okay, that's all the content to review the 3 forms of straight lines equation. If you have any mathematics questions, feel free to submit down in the comment or send into the email that's written on the description. And see you on next video.